Hello, my name is Greg Risteman from Olympus. I'd like to welcome everyone today to this webinar titled Benefits of Olympus RVI Tools for Repeat Inspections. This webinar will discuss the features that Olympus Videoscopes have that will make your repeat inspections quicker and more effective. Real-world examples will be discussed. Our presenter today is Charles Janeczka. Charles is a sales engineer for Olympus Remote Video Inspection products for all the Americas. This informational webinar will last approximately 1 hour. If you have questions, please type them into the Q&A panel in the lower right portion of your screen during the course of the presentation. The chat panel is not monitored for Q&A purposes. If we're not able to get to your question during the live event, they will be addressed personally either by email or phone after the event. Now, without further ado, I'd like to turn the presentation over to Charles Janeczka. Charles, take it away.
Good morning. Thank you, Greg. So I will start off benefits of Olympus RVI tools. We will primarily focus on the core technologies that Olympus has and uses whenever we design and create our video scopes. The outline is, first we'll talk about what we mean when we say a repeat inspection, a concept introduction, the core design technologies that Olympus uses in their design and manufacturing, the issues, the problems that one would have for these repeat inspections, and then I will walk through each individual model and discuss how it presents solutions to those issues and hurdles. Repeat inspections, any remote visual inspection requiring daily, weekly, or monthly repeats for the purposes of quality assurance, fault prevention, fault detection, or defect checking. Preventative maintenance would be one of the larger groups of inspections here. There are many types of remote visual inspection. Most of these types have strict requirements and have personnel dedicated to only that particular inspection. For this webinar, I'm going to focus on the type of inspection that is quick and often unscheduled. You'll more often than not be looking for a general fault or a potential problem instead of something specific. The common hurdles and issues with these repeat inspections: constant searching, setup time, product lifetime, difficult pathways, and uncomfortable or hard to reach areas. The first two, constant searching and setup time, are directly related to the idea of a quick inspection. You want to go in and look for something that is specific or not and get out, as well as setting up. You don't want to have to spend too much time getting everything ready. Product lifetime is always a concern of any sort of investment, especially of the industrial variety. The fourth point, difficult pathways, also has a direct relation to quick inspections. Basically, you don't want to spend too much time trying to get where you need to go and what you need to see. The last point actually relates more to the quality of the inspection than most people realize. Being in uncomfortable places during your inspection can lead to distraction from the task at hand. So when we design our products, we try to reduce this burden so that you can focus on the job and trying to find what you need to see. Next, I'm going to talk about the three technologies that Olympus starts with every time we design and build an RVI product. I'll then explain how these relate to alleviating these hurdles mentioned here. Core technologies. The first, superior image quality. Bright light source, high quality optics, chip light sensitivity, image processing, and bright screen. I expanded a little bit more on the high quality optics. I'll expand into more detail on the specific models when I get to it. Olympus originated as an optical company. Basically, over time, we started to design different and develop new and different products to essentially wrap around those optics. Durability. Robust insertion tube, mil standard 810F. This is on the IPLEX only. drop-tested, durable screen. This is relatively similar to all the different models, but there are some differences and specific points that I will bring out with each model. I do want to point out that we are talking about advanced optical and imaging systems, but they have also been designed to withstand harsh situations and environments because we understand and recognize the sort of environments that they're being used in. Ease of use. Usability is a major concern for us and should be for you because we don't want the product to get in the way of your job. We simply want it to facilitate and allow you to benefit finding what you need to see. So next, I'll briefly mention the 3 scopes that I will be discussing in this webinar. The Series C model is our introductory model. It's simple, easy to use. It's our most cost-effective solution. It is the newest scope that I will discuss on this webinar, and we're real excited about its availability to just pick up and go and use wherever you need to see any sort of defect or potential problem. The Ultralite is effectively the next kind of step up. It's also very small and lightweight, just like the Series C. It has very quick, responsive articulation, interchangeable tip adapters, which I will go into detail later, and true field articulation, which is specific to the IPLEX series. The RT model is our top-of-the-line model that I will be discussing today. During this webinar, it has a very, very bright light source, what we call pulsar pick image processing. I'll go into more detail later. Interchangeable tip adapters, just like the Ultralites, as well as true field articulation, because as mentioned, this is specific to the IPLEX overall brand. So, how does the Series C overcome inspection hurdles and problems? First, I will start with and discuss the constant searching concern. Superior image quality, high intensity LED at the tip. You can see an example here of the actual light coming off, and here is a close-up of the end of the tip adapter. This is the lensing, and then the yellow bar below it is the LED. High quality optics and cost-effective scope. As mentioned before, we started out as an optical company and then just started wrapping products around those optics. We have a proven history of very good high-quality optics, and we're very excited about being able to bring that and introduce that into a lower-priced scope. A 90-degree field of view enables natural zoom while reducing the need to spend time looking due to a narrow field of view. So field of view effectively means how wide, how much of the area you're inspecting can you see at any one time. If you have a much smaller field of view, you have a natural kind of zoom or magnification effect. For reference sake, telescopes typically have fields of view less than 1 degree. So 90 degrees is a very, very comfortable middle point. You have a little bit of a zoom effect, as well as it's wide enough to where typically if you're doing these sorts of repeat inspections, you're not always sure of what you're looking for. So you want to be able to see as much as you can in one go, because without it, you're going to have to look around that much more often and spend more time searching and articulating around. Effective and useful focal range. The focal range simply means what distance from the end of the scope will your target be in focus. So it can get up to about ½ an inch from the tip out to about 6 inches away, and it will still be in focus. Chip sensitivity, image processing, bright screen. This is all kind of lumped into the image processor. The chip sensitivity has to do with coupling it with the superior optics The optics are designed on the Series C to mate and match specifically and perfectly with the chip used here and the sensitivity requirements of it. Next, I'll show just a quick, good example of a simple pipe inspection. The purpose here was to go in and verify that there were no blockages in the piping. So this is a good example of just a quick inspection. Maybe something's not happening, operating properly, and you want to go and make sure everything is looks good inside of the machine so that you can rule out specific issues. Another example. This image is to illustrate that the Series C can handle larger areas that are not always very close to the scope. It's helpful when trying to have a general inspection inside of a larger piece of equipment that may be on the factory floor that you have to crawl around and get access to. The next hurdle, the next issue for repeat inspections that the Series C can handle, or rather constant searching, the other options of the Series C that benefits toward the constant searching. Durability. Robust insertion tube. The insertion tube, entire insertion tube is waterproof, has a tungsten braid on the outside. Waterproof includes oil-proof and typical machine oil and grease and any sort of saline solution. Tungsten braid on the outside of the scope is there, and the scope is designed to be able to withstand repeated abrasion against it so that it doesn't rub the metal away and expose the intricate and complicated wires inside of the insertion tube. Ease of use. So constant searching. You're going inside of a wall. You're going into a pipe to look for blockage. You're going into a casting to look to see if there's any sand or cracking in the casting. You want to spend as little time as possible trying to learn and figure out how to take a picture, how to change the options, how to use any of the functionality of the scope. We want it to be as quick and obvious and intuitive as possible. Series C has a touch screen. It has great articulation, intuitive one-to-one articulation. It stays in place. It is what we call locked all the time. So as you articulate, as you're looking around, you can leave your thumb from the joystick and the scope will be looking in the same location. It will not move back to its central position. Intuitive menus, drawing an annotation for future reference. I'll have an example of that in a moment. Hot buttons, and it's lightweight. So the hot buttons right here, you'll see this is an example of the live screen. Here are all of the hot buttons. What we try to do is design a scope to where about 90%, a vast majority of what you will want to use is just a button away. So you can see the zoom setting right here, zooming in and out of the picture, change the brightness of the image. Here's your main menu function for some of the more advanced options. Here, the view and thumbnail to look at the images that you've taken in the past. And the light button, just simply turning the lights on and off as needed. And then there are a lot of number of notifications and icons on the top right to let you know what's going on in the scope. And then the folder jump button, just briefly, you are able to quickly move around the folder structure on the SD card where the images are being taken so that you can quickly change where the image is being placed for better image organization and management. Here's a couple of examples of drawing and annotation for future reference. The top picture has a standard static image pattern. This is just for reference sake. You can look and see that something in your picture may be one square length, and so if you notice that over here it's about 1 or 1.5 or 2, you'll know that it's about 1.5 or 2 times longer or wider than the image or the reference point over here. You also have the option of creating your own image pattern. As it is touchscreen, you simply draw on the image and you can circle, highlight, point arrows, draw arrows to whatever you're looking at so that you don't have to try to re-explain yourself later if you have to create a report or hand this in to your own customer. Setup time. Ease of use, custom case, very small, lightweight. Reduce when all the accessories are organized. There are simple decals inside of the case to show how to store the unit. Simple battery install, onboard battery charging, quick on button, very short boot up time. The Series C, as with all of our scopes, has a complicated image processor. However, it's just like using a camera. We like to talk about image processors with our video scopes, and we'd like to talk about how it has a lot of computing and some advanced processing happening in the scope. But we also try to keep that functionality and at the same time make it feel like you're using a camera in the sense that you want to be able to just turn it on and start taking pictures. You don't want it to be like a computer or a laptop where you have to turn it on and wait and sign in. You want to be able to grab it out of your case, turn it on, start taking pictures. Simple battery install. Simply put the battery in the scope. There's a short, small little door right there. This is also to show that it has onboard charging. So the idea here is that you can perform your inspection and then simply plug the scope into the wall when you're done, and it will charge the battery while it's inside of the scope. Then you go about your day, and if somebody asks to do another inspection or you need to go look at the casting you just looked at again or look at another one, simply unplug it from the wall and go do the inspection. The battery will have charged without having to take it outside of the scope. Product lifetime, as mentioned, is always a concern of any sort of investment. We luckily have a proven history of designing and creating long-lasting video scopes. The robust insertion tube, as mentioned, it was waterproof, is waterproof, oil-proof, has a tungsten braid on the outside for abrasion resistance. So things like going into hard stainless steel piping, sharp turns, castings, it can rub against these metals and last a long time. Durable screen, the raised areas for added durability if it's dropped, compact design, and a replaceable tip hood, which I'll show in a moment. Durable screen, here's the raised area, which is largely simply there so that if you drop it, this is the part that will touch the ground instead of the actual screen, as opposed to, say, a smartphone. If you drop your smartphone, it's almost guaranteed to crack the screen. Our scopes have been designed to largely be kind of a compact design so that there is nothing sticking out of the scope, so that there's no potential of snapping or popping any part of the scope off. Replaceable tip hood. The Series C, the optics in the Series C are permanent, but we do have a replaceable tip hood so that you can see here, this is the end of the scope. Inside of here's where all of the optics and the actual chip, imaging chip, is inside of this housing. Throughout use, this is just the way the world works. If you rub two metals against each other over time, they will both wear away. So what we created and designed is an inexpensive, very replaceable tip hood that you can screw onto the end of the Series C's distal ends, so that, let's say over time you're going through this casting and it rubs down through the tip hood and starts to, basically it gets through, there's a hole, and exposes the distal end. You simply take it off and replace it with a new tip hood so that there is no danger of rubbing down the actual distal end of the scope where the optics are. Still difficult, or now difficult pathways, ease of use, superior articulation. Unfortunately, it is difficult to explain how good and how intuitive our articulation is over a webinar. You really just kind of need to get your hands on it. Immediate and intuitive articulation, this means that the joystick that you use to articulate is connected directly to the 4 wires that are used to articulate this end of the scope up, down, left, and right, so that whatever image you're seeing on the screen, if you want to go up, you just simply push up on the joystick, and left, you push left on the joystick. As you move, you're directly pulling the wire on the scope, so the only separation between you and the articulation end of the scope is a length of wire. So it's very direct, very intuitive, as well as there's a natural kind of feedback system that if you are, for whatever reason, in a tight space and you're not aware of it, with a Series C you have a direct view, so you can't always see what's on the side of you. If you're in a tight pipe and you're not sure that you're against the wall and you try to articulate right, it will give you resistance, and that's basically a way to know that you have something on the right side of the tip that's not letting you articulate. Spring neck design assists in initiating a tight bend in a pipe and pulls itself out of a bend. I personally am actually really interested and impressed and excited about this design because it's new for us, and I can't say that we're the only ones that have it, but I simply have not seen it elsewhere. Here's a good example of the spring neck design. Here's the end of the tip. This is the light source. This is where all of the optics are. This is the articulation section. When you bend the scope, this is the part that moves up, down, left, and right. From here to, I don't know if you guys can see this portion right here, there's a little black boundary section. From here back is what we call the main body of the insertion tube. From this black boundary section to about this point, you have a spring inside that when you articulate, you're only articulating this section. This spring is here so that when you get into a turn, into a tight bend, it helps guide it along so that it doesn't get bunched up into the corner right here. Another benefit of the spring is that once it goes through the bend, the spring wants to naturally straighten itself out all the time. And so once it's mostly through the bend, it really does kind of pull itself and pop into this straight section of the pipe. I've had this at trade shows and shown it with people internally as well as customers with the setup of this clear piping. And to be honest, the reaction is always great because we like to let people be surprised when we show it to them and they go through the bend and turn and then it pulls itself, and they typically say, you know, oh wow, or they didn't expect that it almost has a mind of its own in getting around these turns. Uncomfortable and hard to reach areas. So as mentioned, you have a ladder, and or you're perhaps crawling underneath a machine. For these common repeat inspections, you're not always able to stand squarely in front of what you're doing. So you don't want to have to worry about how to use the scope. You don't want to spend much time actually figuring out the scope and going through the options, so that you can focus on the task at hand, which is looking and taking pictures and taking video of whatever you're looking at, as well as trying to find potential defects or lack of a defect. Hot buttons. Spend less time looking for the options. It's a small handheld unit, as you can see. Fits in the palm of your hand. You can use the menu with a touch screen, of course, and then also use your other hand to manipulate the insertion tube while you're holding the scope. Small case. It's lightweight, so prolonged inspections are not as uncomfortable. This is something that, again, I mention it, and people who are not familiar with videoscopes or videoscope inspection just have to take your word on it, because it's the sort of thing that doesn't really matter, or you don't recognize how important it is once you actually try to use it out in the field. Imagine spending all day on a ladder or all morning on a ladder holding a scope that is heavier than you would like. Again, you just start to get distracted from trying to hold this thing all day, and the inspection takes that much longer. Quarter 20 screw ports for what we call a magic arm or magnet attachment. There's not a picture of it here, but directly on the bottom of the scope, you have a standard quarter 20 screw ports for anything from a tripod to a magic arm, which is effectively an articulating arm that you can clamp to wherever you want, and have the Series C basically sitting, floating in space so that you can use it without having to hold it if you want to take that option. Next, I will get into the Ultralite and how it overcomes inspection hurdles. The Ultralite is the next step up, the next model with a little bit more advanced features. Superior image quality, again, superior optics. High intensity LED at the tip. High beam mode enables the tip to produce up to 2 times the light for larger areas. With the Ultralite, as the Series C had an LED bar at the bottom of the tip adapter, the Ultralite has tip adapters that have an LED array around the optics, as you can see on the direct views. On the side view, it has an LED array next to it. So that's what you're looking at. That's what these yellow rings and yellow blocks are. We have what is called a high beam mode to produce up to 2 times the light for larger areas. What that does is it effectively just pumps much more voltage through the LED to pump out more light. High quality optics, elimination of optical defects. Like the Series C, but even more so, the Ultralite have high quality optics. And again, I can talk all day about the optics and the science of light, but the point is that the images speak for themselves, and not just the images, but the live images, being able to see what you need to see clearly. Optical defects such as what we call field curvature so if you're looking at an image, and you can see these in a lot of movies actually, the corners of the image sometimes look out of focus, and that's because every optical system creates a curved image. Again, I can go all day and discuss and try to convince people on the importance of high quality optics, but the point is that the image itself is the proof, and being able to see quickly what you need to see. A range of field of view options. So with the Ultralite, you have the added option of tip adapters. So as you can see here, you have all these different options. You have a 40 degree right here. This is a 120, and I believe there's an 80 degree back here. With the Series C, you have a 90 degree field of view. The Ultralite, the most popular is the 120 degree field of view, simply because with that constant searching, if you're not sure what you're looking for, or if you're looking for a specific crack in a general area, if you're inside of a casting and you're looking for a crack anywhere, you want to be able to see as much as you can, because if you have a smaller field of view, such as our 40 degree, you're going to have to articulate and look about 9 times as much, because it's that much smaller. The area that tip sees is smaller than the 120, so the 120 is the most popular tip. However, there are some special situations, such as looking inside of a wall, looking to see structural issues or structural damage, looking inside of a larger machine to see something next to you as well as something on the other side of this large cavity. Something like a 40 degree does help, because, as I mentioned, something like a telescope has less than 1 degree, and so a 1 degree field of view, so it has an incredible magnification. 40 degree tip adapter has a better magnification than the 120. The downside is that you do have to articulate more to see more of your inspection area. A range of focal depth options. With the Series C, you can go from 1/2 inch to 6 inches. With these tip adapter options, you can have a near focus or a far focus. Far focus for the Ultralite starts at around 1 inch and goes to infinity. So if you have something closer than around 1 inch, you're going to want to get to a near focus, and our near focus tips can get up to around 4 or 5 millimeters, effectively right on top of what you're looking at. Superior image quality. Chip sensitivity. The Ultralite has a larger and more light-sensitive chip than the Series C. The images are inherently naturally brighter, simply because the chip is a more advanced, more higher quality chip. The image processor creates a sharp image with vibrant colors. This has a lot to do with the optics and the chip, but it also has to do with the image processor. The Ultralite is a more advanced scope. It can handle a more advanced image processor. Noise reduction. With the 40-degree tip adapter, you can see far inside of a wall to look at structural issues, look into a large cavity. These large areas do not have much light. They're what we call light hungry. The light coming from the LED fills the cavity and then has to come back. When that happens, the chip wants to create a brighter image, so when it does that, it increases its gain. We don't have much time here to talk about all the technicalities of the gain of an image, but when the gain of any scope or any imaging system increases, you also increase the noise of that system, which effectively just looks like static on the screen and makes for a lower quality image, and it also makes it more difficult to look for smaller, finer defects such as cracks or little pot marks, depending upon what you're looking at. Noise reduction helps eliminate this. The Ultralite has an advanced noise reduction algorithm, so it can determine what is actually supposed to be part of the image and what is random noise generated from the electronics. Bright screen for daylight viewing. The Ultralite has a very bright LCD screen. It also has a special material underneath and behind the glass that helps absorb the light so that it doesn't actually reflect and come back to you, so that when you use it outside, all you really see is the screen and the information on the screen. Some examples of high quality images with the Ultralite. The top picture is a great example of the detail and color reproduction. I'm not sure if everybody has good enough bandwidth on the webinar to see all the details here, but you can see some of the scratches. These aren't really cracks. These are just scratches on the right side of the screen. You can also see the blue color of the piping, blue color as a result of the heat affected zone of the weld. So you can go in, travel through the pipe, and very quickly easily see what is happening inside of the pipe if you know what you're looking for. The Ultralite is a great scope to use for general inspection inside of an array of machines for general inspection, just like the Series C. This bottom picture is an example of verifying that this internal nut is still tight, since this particular machine goes through repeated periods of vibration. So you very quickly and easily can see where that nut is on the system. Top picture is a good example of a long focal range and the benefits of a long focal range. You can see down the length of the interior of a wall. Unfortunately, I didn't have a structural beam here, but you can see the benefits of going down and not having to constantly search, not having to use your insertion tube and push all the way down the wall to get closer to something that you're looking for. The bottom picture now illustrates the benefit of a wider field of view. So here we had a thinner field of view where you can see farther down the inside of a wall. On the bottom, this is a large cavity, and a wider field of view is beneficial here. If you had a smaller field of view like this one here, you would only see about this much of this interior part of the machine. With a wider one, you can see everything at a glance and simply don't have to spend all your time looking around for it. So your inspection is done that much quicker. Constant searching still, durability, ease of use, durability. As mentioned with the Series C, a robust insertion tube. The 4-layer construction I did not mention with the Series C, but the Ultralite has a tungsten braid on the outside for abrasion resistance, a rubber layer underneath that for waterproofing and chemical resistivity. If you have a concern about the insertion tube going into any specific kind of chemical, and if you would be interested to know if that there would be some sort of corrosive or harmful effect on the insertion tube, please contact us and we will look into it and let you know. The general rule of thumb is the scope can handle whatever you're comfortable putting your hand in contact with, which at first sound does not sound like it's that impressive, but how many people would like to put their phone into a bucket of bleach? I know I certainly would not. You can. I feel comfortable with it with my hand as long as I can quickly rinse off my hand with water directly after. And same situation here with the insertion tube. It can handle a lot, especially if you have something like a tub of water sitting around and you quickly dump the insertion tube into that tub of water to rinse off whatever may be on the insertion tube. So you have your tungsten braid on the outside for abrasion resistance, the rubber layer underneath it for waterproofing and chemical resistivity. Underneath that, you have stainless steel braid, which I will get to in a moment. That has to do with the maneuverability of the insertion tube to help you get to where you want to go. And then a stainless steel coil inside of that for crush resistance, because the insertion tube has a few different options, or a few different reasons for existing. One is simply to get the optics where you want it to go, to see the target area, to see the potential defects or hopefully lack of a defect in a pipe, in a casting, inside of a larger cavity. It also serves as a protective housing for the power cables for the LED at the tip, as well as all of the high quality, sensitive electronic cables traveling from the chip, from the imaging chip, all the way down to the actual imaging processor and the screen of the scope. Superior true feel articulation, intuitive one-to-one articulation, as mentioned with the Series C. The Ultralite also has wonderful one-to-one articulation. As you move the joystick, it pulls on the wire, which articulates the end of the scope. The Ultralite also has added lubrication for the articulation wires that make the stress inherently natural in wires in any sort of housing. That's less of a problem. So it's much smoother, much quicker articulation. You can articulate freely or lock it in place. The Series C is always locked, so as you let go of the joystick, it is looking at the last thing that you looked at. With the Ultralite, you have the option of moving freely without it being locked or locking it. In the free section, typically people use that for quicker inspections because without the lock, there is no physical, mechanical friction in the system to slow it down. So on the free articulation part, it moves a lot quicker. Constant searching. You don't want to spend, again, too much time trying to figure out how to use the scope. Intuitive menus we try to design if you need to go into some of the more advanced options. Relatively small, short, easy to use menus. We don't want you to spend too much time in the menu. We want you to use all the hot buttons right here. What's not viewed is on the back, but you can see the fingers in the back as a shadow. There is a freeze record button back here where you tap to freeze and hold down to record a picture. Most of what you need is just a button away right here. As the Series C had all of its buttons on screen since it was a touch screen, the Ultralite has all the buttons down here at the level of your thumb or your other hand's finger if needed. Here's the joystick for the articulation. Lightweight ergonomic design, I'm going to be honest, One of people's favorite things about the Ultralite is really just the feel of it, the form factor. Holding it, turning it on, and just walking around wherever they need to go, walking around the factory floor and going in and trying to see where there could be a potential problem inside of a wall, inside of any sort of larger machine, going inside, looking at what you need to look at, and then just walking to the next machine or all over and just spending kind of all day holding this small, lightweight Ultralite. And it just feels good inside of your hand because it's curved to the shape of your finger in the back. Insertion tube maneuverability. Here I'm going to spend a little bit of time about the insertion tube and that extra stainless steel coil inside of the insertion tube. It's tapered flex, means it's more flexible at the distal end than the user end. This is only available on the 6mm Videoscope. We do have 4mm options on the Ultralite. Tapered flex means, let's say you're trying to inspect a pipe. There's a concern about how flexible the insertion tube should be. The entire insertion tube should not be as flexible as a rope, let's say, because if you try to push a rope down a pipe, you're probably only going to get about a foot or so. It also should not be as rigid as something like a fiberglass rod, because you can easily push it down the length of a pipe, but let's say you encounter a turn or need to go off to the side. You're not going to be able to articulate and move into that turn. So what tapered flex is the best of both worlds. At the distal end, where the area where it's going to actually encounter the turn, it's more flexible. And then on the user end, closer to the actual videoscope and the videoscope screen, it is more rigid to add the pushing power to go through something like a pipe, as well as if you're going inside of a larger machine or a large cavity, that more rigid section helps get over the larger areas and kind of jump across spaces. Two braided layers add torsion resistance. We have some scopes, not on these models, but we have some scopes that are up to 20 meters long. And even on those scopes, on the user end, close to the screen, if you twist the insertion tube just a little bit, the end of the insertion tube twists the same amount. There is no slack in the twisting and in the torsioning of the insertion tube. This helps a lot in maneuvering around when you're searching for something. Let's say you articulate up. Instead of articulating all the way around, all you may want to do is articulate it up, keep it there, and then twist the insertion tube to rotate that tip around to see what you need to see. Let's say you're inspecting a pipe to look for cracks or look for defective welds. You can put a side tip on, go down the pipe, find the weld, and simply twist the insertion tube so that it scans the entire inside portion of that weld. The twisting also helps if you happen to get the insertion tube stuck. So what people typically do whenever an insertion tube is stuck is their first instinct is to simply pull hard and quick. And that's the last thing you want to do because you almost will always be guaranteed to get it stuck further. The scope has been designed to be able to be twistable. The tungsten braid on the outside actually helps it now walk itself out. So if you twist back and forth on the insertion tube and then push it back and forth, the tungsten braid will effectively grab whatever you're stuck into and walk itself outside of perhaps it's a crevice or a V-shaped point in the machine. Setup time. Small custom case, just like the Series C. Everything has its own place. There's a small decal to make sure you put everything in its proper position. This is important because with these sorts of inspections, you don't want to spend all day inspecting. You want to take the scope, open it up, pull it out, maybe put battery in if it's not in there, and turn it on. Very short boot up time. Removable media is easy to install and use immediately. On the side of the scope, there's a small door where it accepts an SD card. You can pop that card in and out. It does not have to be on to put the card in and out, just as long as it's not taking a video or a picture when you remove the card. It's fine. Product lifetime, durability, robust insertion tube. We've mentioned this. 4-layer construction. The insertion tube is the part of the scope where all of the potential abrasion and chemical reactivity is going to happen. We have a long history of developing more and more advanced insertion tubes to make sure that they last. Durable screen, raised areas for added durability if dropped, just like in the Series C. The Ultralite also has Gorilla Glass covering the screen. So that means it has passed the 1-meter steel ball drop test. The test there is obviously to drop a steel ball onto the screen. If somebody's not familiar with videoscopes, they look at it, they see an image on the screen, and they see a small camera, a small set of optics on the end of the scope. They immediately equate that to something like a smartphone or the camera on a smartphone, which makes sense if you don't have much videoscope experience. But the point I'm making is that these are very industrial machines. How many smartphones would you mind dropping a steel ball a meter above onto the screen and not worrying about it cracking and ruining the product? Compact, durable body. Small, very similar size to the Series C, also very compact. I don't know if you noticed with all the pictures, but there is nothing sticking out so that if it does get dropped, nothing's going to stick out and snap accidentally. IP55 rated, waterproof, weatherproof, dustproof, all that, not a concern for the scope in general, not just the insertion tube, but the main body of the scope. Difficult pathways. True feel articulation, free articulation or locked articulation if needed, immediate and intuitive, tapered flex, more flexible at the distal end than at the user end. So for the more difficult pipe paths, the tapered flex really does help because it becomes very easy to go around those turns. Also, you have the pushing power on your side. 2 braided layers add torsion resistance, twisting at the user end, twists at the distal end. This also helps in combination with the articulation. This is why our articulation is so great. We've designed it to be so good because as you're using the scope, once you become really familiar with it and become an expert at it, what you effectively end up doing is push and pull the insertion tube, twist it back and forth, as well as articulate. You'll do all 3 of those things without even thinking about it. So we try to make it as quick and intuitive as possible so you don't have to even worry, is it behaving as quickly and possibly as quickly and intuitively as it can. So that all you have to worry about is looking at how do you get to where you want to go. Hot buttons. Hot buttons, I've mentioned. And less time spent looking for options, close to about 90% of what you want to do is going to be right in front of you, just a button away. Some of our buttons have multifunction options, like the freeze record button in the back of the scope. You tap it to freeze the image. That's not a picture that's taken. That's a temporary image. You tap it again to unfreeze. You can tap it and freeze the image and then hold it down for about a second to actually take a picture. And then if you hold it down for about 2 seconds, that will initiate the creation of a video. Just like the Series C, there's a 1/4-20 screw port attachment for a magic arm or magnetic attachment, so that you don't have to hold it all day if you feel like you don't want to. There are also straps available. Next, the RT and how it and its design overcomes these inspection hurdles that we've talked about. Constant searching, superior image quality, high intensity LED at the handle. A lot of this is kind of reiteration because as I mentioned at the beginning of this webinar, I'm discussing the core technologies of Olympus. We have the same core technologies whenever we design every product that we make. So there is some very common design concepts from one scope to another. However, the more advanced modeled scopes have more advanced features. One of the more advanced features of the RT is a high-intensity LED at the handle. That's why this picture is right here. Inside of this portion of the handle is a high-intensity LED. This black metal fin is a heat sink for this LED. Macro LED is connected to a fiber optic bundle. This turns into the insertion tube, so the fiber optic bundle is inside of the insertion tube and attaches directly to the macro LED in the handle. The optics of the RT are different than the optics of the ultralights. Because the LED is inside of the handle, it does not have LEDs at the tip adapter. They are high-quality optics. The RT is also newer than the ultralights. So because it's newer, we developed newer, more advanced optical designs into our tip adapter. And that's just something that any technology corporation tries to do, is try to develop newer technology with newer and more advanced products. 120 is the most popular field of view, as with the ultralight. A range of focal depth options, as with the ultralight, but even better. As mentioned, we redesigned a lot of these optics. So depending upon the tip, the far focus starts at around 3/4 of an inch and goes to an infinity. Near focus starts at just a couple of meters, so really right up against whatever you are looking at. Most of these types of repeat inspections, you're not going to want or need to get that close. You're going into something larger and just looking for a potential fault, or you have a specific area that you're going to look for. You will most likely just need a 120-degree far focus tip, because you're typically not going to need to get closer than 3/4 of an inch. Just a couple of examples of the tip adapters. Just black on top. Here's not really very visible, but the optics are right here. But the point here is that just to show and reiterate that the LEDs are not at the tip. They are at the base handle. There is a diffraction gate right here to where the light guide butts up against, and then this diffraction gate or diffraction optics spreads the light out over to a very controlled area onto your target. Chip sensitivity, the RT has an even larger and even more sensitive chip than the Series C or the ultralights. Again, this is a newer, more advanced scope. Image processing, Pulsar PIC is a newer image processor that we developed for this scope. Dynamic pulse lighting, the scope, it's the lighting on the scope itself actually pulses at certain brightness levels. It also changes its own brightness. With the Series C and the ultralight, if this light is on, the light is on. With the ultralight, you can turn on high beam, and it turns it 2 times brighter. With the RT, dynamic pulsing, noise reduction, automatic image brightness enhancements such as gain, exposure, and shutter speed. All of this is handled automatically and intelligently by the Pulsar PIC image processor. All you need to worry about is use the brightness button on the handle. Just a few examples of some really high quality, sharp images that are available or through using the RT. Durability, the same sort of insertion tube as the ultralight and Series C. True field articulation, just like the ultralight, except there is an added feature of a motor assist in the handle on the RT. So as you articulate, it kind of wraps around the motor grabs the wire and helps you pull it, just kind of like the power steering in your car. Ease of use, intuitive menus, hot buttons. The handle is separate from the screen because it's a larger screen, so the handle is where the articulation joystick and all of the menu options and hot buttons are. Tapered flex, just like the ultralights. 2-braided layer for torsion resistance to help get you where you need to go. Custom case, ease of use. This is one of our core technologies, so we try to keep it with the RT. Not very much of a difference here. the RT uses a USB stick on the back of the screen instead of an SD card. Product lifetime, durability. Same sort of insertion tube as the Ultralite. It's operable in all weather, IP55. It also has the added mil standard 810F rating. So it has gone through a series of harsh environmental tests, such as blowing rain, dust, high humidity, iced rain. Durability, the body has passed the 1.2 meter drop test. So it has been tested, it has been dropped from 1.2 meters and passes without a problem. If you can go onto our website, there are some really great videos of the scope under icy conditions or being hosed down by what's almost a fire hose amount of water. True feel articulation, motor assist, as mentioned, the tapered flex, more flexible at the distal end than the user end, and then the two braided layered adds for the torsion resistance to help maneuver it into those tight spaces. And this is a good magnification of that tungsten braid on the outside for the abrasion resistance. Ease of use, hot buttons are all on the handle. Almost everything you need to use, all the menu options are on the actual handle. That brightness, I want to reiterate that there are about 5 different variables that the scope automatically and intelligently controls as you turn the brightness up or down. There's another 1/4-20 screw port on the back of the scope so that you can attach it to wherever you need to if you want to with a clamp or a magic arm or a tripod, and you'll have the screen will be facing you and the tripod behind it. And then there's also a clip on the back of the scope to attach the handle so that you can easily click it on and walk around with it from where you have it set up in your office or your warehouse and walk over to whatever your machine you're inspecting. So, quick summary over what we discussed. The 3 core technologies, not just the only core technologies, but simply the ones that I discussed here. Something that we deal with whenever we design or create any of our video scopes. Superior image quality, we started out as an optics company, just simply wrapped products around that. High chip sensitivity and image processing. Image processor and chip sensitivity are things that are just getting better and better every day with more advanced technology. Everything's getting smaller and faster. Ease of use, hot buttons. We have always spent a lot of time thinking about and designing most of what you will need and put it onto the handle right next to your fingers, just a button press away. Durability, robust insertion tube, tungsten braid on the outside for abrasion resistance, a rubber layer for waterproofing and chemical resistivity. There's a mil standard that we pass for increment weather so that you can use it in all sorts of environmental situations, and a very compact, durable body that passes the 1.2 meter drop, and Gorilla Glass as well on the screen of the Ultralite. Thank you very, very much for listening, logging in and listening to me today in this webinar, and hopefully it was beneficial. I believe we may have some questions, so we can deal with those later. Again, have a great day, and thank you for listening. I will hand it over to Greg now.
Thank you, Charles. On behalf of Olympus, I'd like to thank all the attendees for joining us today, and Charles for his expertise and participation in today's event. We hope this material presented was informative and useful. This webinar, along with a Q&A session, will be archived on our website at www.olympus-ims.com. Everyone who registered for this event will receive a follow-up email with links to the archived presentation. That's going to do it for today. We're going to thank you again for attending, and we'll see you again next time.